Yes. Thank you, Lily. Yeah, so this is perhaps in this among this group of people a slightly odd user case. Oh, there we are. Let me start to begin with just the question here. What is the case for a cultural heritage institution to use HPC at all? So the background here is what we like to call the transformer transformation. In 2017, Google Brain came out with a new way of training large AI models based on text. And before that, AI models, they required supervised training and a lot of annotated data. But after the transformer architecture came out and came into use, what is required is unsupervised training and massive annotated data. And cultural heritage institutions like the National Library and the National Archive, who is also represented here somewhere, I don't, there you are, hi, have exactly that. We have high quality, massive humanistic data, and with humanistic data, I mean text, sound, images, and videos. So we have that. And when it comes to the National Library, we have legal deposit laws that require everyone who publish anything, a book or whatever, to send a copy to the library. So the collections have been growing for hundreds of years, and the growth rate is also increasing naturally these days. And the deposit loss has been extended to include all modalities. So we have text, sound, images, and videos in all formats, physical and digital. So we're closing in on 26 petabyte of data, which is a lot. And KB, the National Library, has the largest, broadest, and deepest collection of humanistic data for the Swedish language. And the collections, they include objects like books, commercial leaflets, pizza menus, computer games, school photos, handwritten manuscripts, TV and radio broadcasts, millions and millions of hours of TV and radio broadcasts, newspapers and magazine, and etc. It just goes on. So we are a governmental hoarder, as it were. What should we use this for? Well, the paradigm of transferred learning is where we train these models, or where Google started to train these models. So the transformer models, they have a general capability, for example, understanding texts. That general capability can be transferred via fine-tuning to smaller, using a smaller annotated data sets to specific domains. So not just understand text, but please understand financial text or medical text, or to a special capability. Please point me to all the part of speech. Part of speech is what kind of words are in the text. Are there verbs? Are there nouns, etc.? Fine-tuning is not data intensive and it's not computationally expensive. So there's a huge usability downstream from the larger models. However, ground training of these transformer models takes a lot of data and it takes a lot of computational power. And there's a never-ending need for GPU hours in HPC environments. So for a low to mid-resource language, such as Swedish, the Cultural Heritage Institution have the possibility to train state-of-the-art AI models based on our collections. This is true for us, it's also true for the National Archives and a few other institutions as well. And we can train models that are on par with the models for high resource languages, for example, English. And the possibility to train these state-of-the-art models, it sort of translates into an obligation to do so, to support, which is sort of in the instruction that we get from the government. It is to support the quality of Swedish research and to support a strong development of the democratic society. This includes that Sweden should be sort of in the forefront of the development of AI. And this includes the transformer models. So the fact that we can actually train these models is also an obligation to do so. And also, since we're a governmental agency, the democratic sort of logic is inherent in our models. And this is especially important when we're balancing the data that we put into the models. So we always try to represent all varieties of Swedish, for example. And we can do that. And we also have enough data that we can throw stuff away that would otherwise result in unbalanced and overly biased models. So we want all varieties of Swedish, even the poorly spoken, poorly written, kind of Swedish as well, but we don't want that to sort of bias the models in any way. Well, to accomplish this and to make use of the collections, we need access to HPC-level computational resources, since ground training of transformer models is both data-intensive and computationally expensive. As an example, the first large transformer that we trained in-house on our lab, it took us 7 months to train that. We used 2 gamer GPUs to do that. And also moving the model around, training it with open data in the cloud, etc. It was a hassle, actually. And models keep getting bigger. So the first model we trained was the BERT base, and then the model sizes has just exploded, basically. Wave to Vec is a sound model. BERT large, I think our BERT large is currently the state-of-art text model. It will be probably passed soon. T5 is a model that can both produce text, both read text, but also produce text. And the model size in terms of number of artificial neurons is just exploding. And this is what it looked when a few years ago, and then we have the GPT-3, which sort of is even bigger. So here we can even see our first model. It just disappears on the y-axis in terms of size of the models. And this, just to train the models in these architectures, takes a lot of computational resources. And this is, I think this is the same information we have here. Every dot here is a completed model. And what this figure basically tells you is either you need a lot of time or you need a lot of computational resources to train these models. Constantly looking to gain access to more GPUs. For us, we have used the Vega pod in Slovenia, and shout out to the awesome Vega staff. We love you. The lab was the first governmental agency to actually use the European joint undertaking systems. And we used the Vega pod, and we now have a continuation project going on at Vega and other applications as well for regular access at Meluxina in Luxembourg. And we're also trying to see if we can port our code, training code from the NVIDIA environment that in Vega and Meluxina to the AMD environment in Lumi. How do we use the HPC resources? I wanted to just show you one user case to get you an idea. This little table here over to the, what is it, your left, is the description of what was broadcasted from the Swedish radio in 1986, the first March 1st. Calm music and news. But what did actually happen that night? Well, this was the night that the Swedish Prime Minister was shut down in the streets of Stockholm. And this information is completely obscured in the traditional library description of this data material. So if you're interested in this, you can't really find it. But using our transformer sound model, the VoxRex, we can transcribe all the content in the data object, and then we can start looking into that. Here, just using this very simple, looking for the name Olof Palme in the collections. And then we see here the murder occurs here, and there's an explosion naturally of mentioning of Olof Palme. So this previously completely obscured black sea of data immediately becomes accessible for researchers and others. So using the KBLab sound model VoxRex, we can describe the content of the radio broadcast rather than relying on metadata that is sort of external to the actual data. So digital objects that has been dead for practical purposes can be brought back to life. And the VoxRex, our sound model, is state-of-the-art because we have access to almost unlimited amount of hours of sound with complete representation of all the varieties of spoken Swedish. So you have all the dialects. I will not try to imitate them now, but and for this to be true, we also have to have the data in combination with the HPC resources to train the models. And so it's a lot of data, it's a lot of computational resources, and also competences at the lab. And if you're Swedish speaking, you may want to guess what the hardest dialect is for the model to understand. And the answer is Västskånska. So that's really, really hard. We have one of the data scientists at the lab. He incidentally has a wife from western part of Skåne, and the model is completely just, no, I don't know what it is. But the other dialects is sort of, yeah. This is all about one application at the National Library, and VoxRex is fine-tuned versions of the model is downloaded around 200,000 times per month for purposes and application that we don't really see. We don't know what they're doing with model, and this is in line with the idea of a national library. We don't follow up, for example, if someone borrows a book. We don't ask, what are you going to do with that book? And this is the same with the models. We release everything open source, unless there are security restrictions related to the models, which it can be if they have a strong generative capability to generate text or something. So we don't really know what people do with the models. We can't really see that. So the societal benefits from the KBLab model is huge, but it's largely unknown. People have been trying to calculate the societal benefit from the models in the public sector. And looking back to the KBBERT, which is the first large text model that we trained, they have estimated that the societal net benefit from that model is around 840 million Swedish kronor over a period of 4 years. But that's just in the public sector and just one model. I think that the hour is late and so forth, so I will stop there. And if you have questions, you can ask me, but I will also recommend that you talk to Robin, who's sitting somewhere in the audience there. He will be at the dinner, I think, tonight, or at least he will be here tomorrow. And he is the project leader of our HPC projects. And I will just say that what we're doing next is we're moving into larger machines, Meloxina, etc., but also into larger data sets over more modalities, and also training models across modalities. So not just a text model and an image model and a sound model, but combining that and also looking into video models. Thank you.
Thank you very much.